that the pairs of organic compounds that are isomers is. Now here we have ethanol and here we have propanol. Now for two compounds to be isomers of each other, that is one, they must have the same molecular formula. They must have the same molecular formula, because isomerism is a phenomenon whereby two or more compounds have the same molecular formula but different structure. So this one, so let's look at it here. Here we have ethanol and what? Propanol. So are they isomers of each other? The question is no. They are not isomers of what? Each other. So now let's look at it very well. Amazing question now in JAMB. Now, one part of organic chemistry you never escape question on is called isomerism. After knowing the hybridization and the nomenclature aspects, the next you want to focus on is the what? Is the isomerism part of organic chemistry. And isomerism is, when we look at the word isomerism, now the definition is what? Is the phenomenon whereby two or more compounds have the same molecular formula but different structural formula. So that what isomerism. So isomerism is what is divided into two parts. Now isomerism is divided into two parts in general. So here we have isomerism is divided into what? Two parts. Here we have what? The structural isomerism, and here we have what? Here we have stereoisomerism. It's okay, stereo what? Isomerism. Now this social isomerism is divided into what? Three main parts. Now here we have the chain, the position, and here we have what? The functional. So now we're talking about structural isomerism. Here we call the chain, the position, it was functional group isomerism. Now stereoisomerism is divided into two main parts. Here we have the geometrical isomerism, and here we have what? Optical what? Isomerism. It's okay. So that is why you want to take into this one here. Now, in this class, I just want to do a revision class because I've created video on the structural isomerism and stereo isomerism. I've created different videos that explain chain, positional, and functional. And I've also produced videos that explain geometrical and what? Optical what? Isomerism. So like this video is not like I'm trying to explain everything again. I'm trying to do what revision what questions. So I will be leaving the link to these videos at the description below, so that you should go and check out those videos, and how you be able to what? Answer this question here, because with knowledge of this type of isomerism, that is how you'll be able to what? Answer variety of questions in the exam. So this video here is just like a revision class, solving of what? Past questions you're going to see in your exam on what? Isomerism. So please make sure you check out the complete video I've done on my YouTube channel. Please, I will leave the link at the description below. You get, so I can watch, access those videos for free. So you are not paying, and you are not paying for that video. But I will try my possible best to explain each of these questions and how we arrive at our answer, so that by the time you finish watching this video and check out that video, you get what? A better understanding, right? So let's jump into what the first one here. So if you look at the first one here, if you look at the first one here, they say which of the following are isomers. Now remember, isomerism means what? They have the same molecular formula but different structure. So what you want to understand here is that whenever you see a molecular formula, you have to say how many times or in what way or how many ways can you rearrange this molecular formula to get different structure. So when you see a molecular formula, can this molecular formula have different structure or not? So I want to show you that here. So if you look at this one, C2H4. Now, C2H4 is what? Is an alkene. Is what? Is ethene. Yeah, is it what? Ethene, right? is an alkene. It's in with what? It's a double bond. Do you know the reason why? Because it have what? Two carbon. Two what? Carbon. One, two. Just that. And each carbon have two hydrogen, because how many hydrogen do we have here? Here we have four hydrogen. Now, two will be here and two what will be here. Do you understand? Now, if you checkmate it very well, remember, carbon is tetravalent. So carbon must have four bonds. So now whenever you draw a structure and carbon is now having a four bond, or carbon is now having four bond, it means that there's what? A second bond. If you check from here, carbon here, this carbon here is having three bonds. So if I should ask here, how many bonds does it need to complete four bonds? Of course, it's one. So this also need one. So that is, there must be what? A double bond. Do you understand? So that's why you see all alkenes have what? A double bond. Alkanes all have what? Single bond. Alkyne have what? Triple bond. I have done a complete video on hybridization, and I've done a complete video on nomenclature. So please check out that video. I've done a complete video on nomenclature and what hybridization. Check out that video if you still don't understand hybridization and nomenclature. I don't have time to start going back to what I've done again, right? So now C2H4 is, this is what molecular formula, this is what structural what formula. So of course you cannot rewrite this again to get a different structure. You get, so this one is out of it. There's no way you can rearrange this one here to what, get a different structure, because isomerism simply means what? How many possible ways can you write this one here to get a different structure? You get, and when I say different structure, that different how you pack nomenclature. Do you get that? So this one is out of it because it can only be C2 H2. You get, so you cannot write this one again. So this one is out. So but let's look at this one here. C for H10. C for H10. What does it mean? It means that here I have four carbon, 1, 2, 3, 4. It's okay. Then 10 hydrogen. So here we say 1, 2, 3, 4, 5, 6, 7, 8, 9, and what? And 10. Can you see that? So C4H10 is okay. This is what? Molecular formula. This is what? Structural formula. And this structural formula is called fully display formula. I have done a complete video on how to draw structure of what? Organic compounds, where I explain the condensed formula, the fully display formula, and what? Skeletal what? Formula. You can check out that video. You get, I've done a complete video on that. So this is what fully display formula here, but you can write in a condensed way. It's going to be CH3, CH2, CH2, CH3. So can you write this one again to get a different structure? The answer is yes. You get, now the answer is what? Is yes, because you can rearrange this one to get a different structure. You can arrange like this: CH3, CH3, and what? CH3. Now this one is called butane. It's called what? Butane. But it's called what? 2-methyl what? Propane. 2-methyl what? Propane. So you can rearrange one to get a different structure, because if you check it very well, this will have C4H10, right? This will have C4H10, because 1, 2, 3, 4. Here we have 3 hydrogen, 1 hydrogen, 3 hydrogen, 3 hydrogen. 3 plus 3 plus 6 is 9 plus 10 plus 1, which is what? 10. So butane and what? 2-methyl propane have the same molecular formula but different structure. Do you understand? So let me explain it again. When you say different structure, that is, they have different IUPAC name. So you can rearrange a molecular formula that have what? Different IUPAC what name. So two or more compounds that have the same molecular formula but different IUPAC name, they are called what? Isomers. They are called isomers of each other. So the phenomenon is now what? Isomerism. So C4H10 can be arranged to butane and what? 2-methyl propane. So this one is what is the correct what? Answer. So C4H10 have what? 2 possible isomers, butane and what? 2-methyl propane, right? Now let us checkmate the rest of them so that I can still explain to you. So C3H8 have 1, 2, 3 carbon atom with what? 8 hydrogen, right? So this one can take 1, 2, 3, 1, 2, 1, 2, and 3. Can you see that? So if you check me very well, now please pay close attention here. If you check me very well, now 1, 2, 3, 4, 5, 6, 7, 8, 8, right? So this one also is that was CH3, CH2, CH3. Now you ask yourself, can I rearrange the chain to have a different structure? The answer is no. Because if you should do it like this, CH3, CH, CH3, here we have CH3 here. Now this one and this one are the same thing. So here we have what? Propane. Here we have what? Propane. Do you understand? Here we have what? Propane. Here we have what? Propane. So in the sense that you cannot rearrange it to get different structure. You get. So this one does not have what? Isomers. It does not have what? Isomers. So let's look at what? C2H6. 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 Here we have 1, 2, 1, 2, 3, 1, 2, and 3. Can you get a different structure? No. So this is just so here we have CH3, CH3. So you cannot get a different structure. So it's not possible. Do you understand? Now E is C6H6 is a benzene ring. So it's like this. A benzene ring cannot have isomers. Do you understand? A benzene cannot have isomers, so it's out of it. So the correct answer is what? Is B, C4H10. Do you understand? So let's look at question number 2. If you understand this first one, leave at the comment section that you understand this first one. So let's look at what question 2. Look at what question 2. Now in the question 2, you see that the pairs of organic compounds that are isomers is. Now here we have ethanol and here we have propanol. Now for two compounds to be isomers of each other, that is one, they must have the same molecular formula. They must have the same molecular formula, because isomerism is a phenomenon whereby two or more compounds have the same molecular formula but different structure. So this one, so let's look at it here. Here we have ethanol and what? Propanol. So are they isomers of each other? The question is no. They are not isomers of each other. So now let's look at it very well. So let's look at it. So here we have ethanol is like this: CH3, CH2O. It is called ethanol. Do you understand? Then propanol is like CH3, CH3. That is why if you are a chemistry student, you don't know organic compound, you don't know organic chemistry very well. Please, what I will advise is this: make sure you go to my playlist. I've done a complete video on organic chemistry. Go to my playlist, right? Go to my playlist. Now go to my YouTube channel. You see. I've also showed you the playlist, right? Now when you go to the playlist, you see organic chemistry. Go and watch every videos on organic chemistry one by one. You get. Go and watch every video on what organic chemistry one by one, so that you're able to understand this here. So these two cannot be pair of what? Isomers. Do you know the reason why? Now, how many carbon do you have here? You have two carbon. How many hydrogen? 6 hydrogen, what? 1 oxygen. Do you understand? So it's going to be C2H6O, right? Now, 2 carbon, 2. Here we have 3, 4, 5, 6. So now what about this one? Here we have C3H6O. So are they isomers of each other? The question is what? Is no, they are not isomers of each other. Why? Because they have the same hydrogen, the same amount of oxygen, but the numbers of carbon atoms differ. So they cannot be what? Isomers of each other. So it's out of it. You get? Do you understand? So let's look at what benzene and what methylbenzene. So if you look at benzene and methylbenzene, look at what benzene. Benzene is like this: C6H6. Methylbenzene is CH8. Do you understand? So this benzene. So now let's draw the description of benzene. Benzene is like this. This is called benzene. This is what benzene. This is what benzene. 1, 2, 3, 4, 5, 6. It's okay. So if you should draw a description like this, So here we have double bond here, double bond here, double bond here. Hydrogen, 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 and what? Hydrogen. If you check it very well. So this structure is this structure, right? 6 is H6 benzene. Now look at what methyl benzene. Now it's also a benzene, but it have what a methyl group. It have what a methyl group, like CH3. Do you understand? So just like this structure of benzene here, you know, like this structure of benzene here, right? This structure of benzene here, we have hydrogen, 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 hydrogen. Here we have CH3. Can you see that? So if you check very well, two of them do not have the same molecular formula because here we have this one, you have 6 is H6, right? This one have 1, 2, 3, 4, 5, 6, 7. 7 come out here, C7H, C7. Now if you look at the hydrogen, 3 hydrogen, 3, 4, 5, 6, 7, 8, 8 hydrogen. So they don't have the same molecular formula. You get that? So they are not isomers of each other. They are not pairs of what? Of isomers. They are not pairs of what? Isomers. So let's look at what the C part. Boot 1 in and boot 2 in. Now this one is the correct one, which I'm going to explain to you. C is what is the correct option here, which I'm going to explain to you. So here we have boot, one what's in, right? Boot 1 in. I have boot 2 what's in. So boot 1 in, you're like butane. It's okay. So it's going to be C for now. What is general formula of alkane? The general formula of alkane is what? CnH2n. Do you understand? The general formula of the alkane, because in and in the general formula of alkane is what? CnH2n, right? So boot means what? 4 carbanions. My n is what? 4. My n is 4. So if you substitute 4 here, it's going to be C for H2 4. We're going to be C for H8, right? So two of them should have the same molecular formula here, but we're going to draw the structure because when you talk about boot is what? 4 carbon each. So the molecular formula is what? C for H10. But now let's draw the structure. Let's draw the structure, right? Boot means 4 carbon atom. 1, 2, 3, 4. It's okay. 1, 1, 2, 3, 4, right? Now this En means what? A double bond. Now we want to see En is what? Is a double bond. Now the position of double bond matters a lot. Here they say 1. So if I show my number here, 1, 2, 3, 4. My double bond is a carbon what? Number what? 1. The same here, 1, 2, 3, 4. It's okay. 1, 2, 3, 4. Now 1, 2, 3, 4. If you check it very well, I came back to I want a double bond, so you can put double bond here. You see that? Now the next one I want to do here is what? This was your hydrogen. 2 hydrogen will be here because why? Carbon is what? Is tetravalent. That is, carbon want to form 4 bonds. Tetravalent. Here we have what? 1 hydrogen. Here we have what? 2 hydrogen to make 4 bonds. Here we have what? 3 hydrogen to make what? 4 bonds. Yeah, what are you going to do here? Here going to be 3 hydrogen. You're going to be what? 1 hydrogen, 3 what? Hydrogen. It's okay. So if you check it very well, they have the same molecular formula. 1, 2, 3, 4. 1, 2, 3, 4. C4H. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 here. Do you understand? So now two of them have the same molecular formula, but different structure. Now, why are they different in structure? They are different in structure because the position of the double bond is a carbon 1 here. Position of the double bond is our carbon 2 here. If you're not subscribed to the channel, please hit that subscribe button and turn on the notification bell or icon so that whenever I upload a new video on this topic or any other topic chemistry, you'll be notified that a new video will be uploaded so I can go watch that video. That will help you understand every topic faster. Now, if you want to do any video for you, please leave it. If there's any topic in chemistry that is giving headache, leave it in the comment section. I will respond to that. I will produce videos on that for you. Look at what question 3. Question 3 and question 4 are the same. So if you look at question 3, I say that the numbers of isomers that can be obtained from C4H10 is. So now when I see kind of question here, you have to say if it's an alkane. So if it's an alkane, then we have a simple formula you can apply in order for you to get numbers of what possible isomers in which what any alkane we have. You understand? So, but how do you know if it's an alkane? Therefore, you have to what know the general what molecular formula of the alkane. So the general molecular formula of the alkane is what CnH2n plus 2. Where n means what numbers of what carbon atom. It's okay. N equals to what numbers of carbon atoms in the what in the molecule. Numbers of carbon atoms in the what in the molecule. You get. So before you can apply the formula here, if you, like what I said, you must therefore have to say if it's an alkane or not. So if you just know like this, C for H10. Now let's test this guy. If this guy will suit this formula here. So my n here, my n is what is 4, right? Now let's place it here. If you are going to get this one here, so it's going to be C for H2 for plus 2, right? So what are you going to do here? C for H. 2 times 4 is what? 8 plus 2, which is what? 10. It's the formula here. Right. So this guy is an alkane. So whenever they are asking you the numbers of possible numbers of isomers in which an alkane we have a simple formula to do that. So here is formula here. Numbers of isomers, numbers of what isomers equals to what 2 are n minus 4 plus 1. Right there. So with this simple formula here, you can know any possible numbers of you can know the possible sorry. With this formula here, you can know the numbers of isomers in which what any alkane provided is what is an alkane. So when a compound is being given to you, first of all test if it's an alkane or not. What is an alkane? They can apply this formula. This one is only applicable to what? To the alkane, that is all single bonds. Without if it's not alkane, this formula will not work, right? So C for H10 suits this formula here. General molecular formula. Do you understand? My n is what? My n is 4. So what are the possible steroids? What are the possible isomers? So here we have numbers of isomers. Numbers of isomers equals to what? 2. My n is what? 4. 4 minus 4 plus 1. So what are you going to get? 4 minus 4 is what? 0. So it's going to be 2 raised by what? 0 plus 1. Now 2 raised by 0 is what? Is 1. 1 plus 1 equals to what? 2. It means that this compound can have what? 2 possible what? Isomers. You get two possible isomers, which is what? Butane and what? Which is butane 2-methyl propane, which I've drawn before. Do you understand? I did it where we did this one here. It's okay. So so this one have so how many possible stereoisomers? How many possible isomers can C for H have? The answer is what? C. The answer is what? Is C. That is the answer. So what about this one here? How many isomers does pentane have? How many isomers does pentane have? Pentane is what? C5H12, right? C5H12. So if I have something like this C5H12, C5H12, right? My n is what? Is 5, right? So numbers of isomers. Numbers of isomers is what? 2, 5 minus 4 plus 1. 5 minus 4 is what? Is 1. So 2 is for what? 1 plus 1, right? It's going to be 2 plus 1, which is what? Is 3. So these guys have what? 3 possible what? Isomers. Do you understand? So what about if you ask them like this? C6, okay, C7H16. Okay, how many possible isomers can this one have? First of all, you have to confirm if it's an alkane. So is this one alkane or not? How do you know if it's an alkane? Put 7 here and see if you are going to get this one here. So if my n is what? Is 7. What is molecular formula? It's going to be C7H7, which is what? 2 times 7 plus 2. So C7H, 2 times 7 is what? 2 times 7 is what? Is 40 plus 2 is 16. So it's what? It's an alkane. So look at the comment section here. C7H16. How many possible isomers is it going to get? So leave at the comment section. So we are done with question 3 and what question 4. So let's move to what next set of questions. Let's look at what next set of questions. Question 1, question 5, 6, and 7. So let's look at it here. Now the good thing here is that some of these questions I'm asking here, I'm doing here in this video, you are going to see some of them in the exam. So that's why you want to pay close attention. Now the first one, now number 5 is an isomers of C5H12 is. So they ask you, what is an isomers of what? What is an isomers of what? C5H12. Right there. So that is what other structure can you get in what C5H12. So in C5H12, here we have C5H12. That is why I say that if you have not watched my complete video on structural isomerism, where I explain what structural isomerism is all about, chain, position, and what functional, please try as much as possible to go check out that video. Probably when you finish watching this video. Do you understand? It's very important to check out that video. So C5H12. So here we have 1, 2, 3, 4, 5. Is okay. So now let's put what our hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now the main reason why you have to draw the structure. Now you have to draw the structure in order for you to know the other isomers can possess. So now this is called fully display. Now this is called structural formula. This is called molecular formula. Idea. Molecular formula or structural formula. So you have this is called fully display formula. Now when you have fully display formula, that is all the atoms are what are shown how they are connected to what different atoms and fully what and written what in their bonds. So now let's condense it. Now condense formula means what you are grouping them. For example, yeah, this carbon have what 3 carbon atoms, so it's going to be CH3, right? Connected to what? CH2. Connected to what? CH2. Connected to what? CH2. Connected to what? CH3, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now this one is called pentane. It's called what? Pentane. Now remember, if my n is 5, is an alkane, right? How many possible isomer can you get when n is 5? Remember, you have 2 raised to what? N minus 4 plus 1, right? So it's going to be what? 2 raised to what? 4, 5 minus 1, 4 plus 1, right? So 2 raised to what? 1 plus. So these are going to have 3 isomers. So this one can have what? 3 isomers. Now pentane is 1. They ask you to give another one. So this type of isomer is called chain isomerism. Chain what? Isomerism. So to get a different structure, that is, you have to what? Now the parent chain is 5. Now let's reduce the parent chain to be 4. If I reduce the parent chain to be 4, here we have 1, 2, 3, 4. It's okay. Now I now have 1 carbon left, right? Now where can I place the carbon atom that will help me to get a different structure, right? So now whenever you're placing your carbon atom, avoid these 2 ends. It's okay. You cannot place it here, cannot place it here. No. Now avoid this one here, the starting one and the ending one. Avoid those 2 carbon. So now what I want to do here is we'll place the carbon atom, the last carbon atom, either here or here. So if I should place it here, or 1, 2, 3, 4, or I should place it here, it's okay. Now how many hydrogen we shall have? 3 hydrogen. 1, 2, 3. What about this one here? 1, 2, 3. What about this one here? 1, 1, 2. 1, 2, 3. Right? The same thing here. So this also is saying about CH3, CH3. Here we have CH2, CH3. If you check it very well, now this guy and this guy have the same molecular formula, which was C5H12. 1, 2, 3, 4, 5. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you see that? So Pentane and this compound have the same molecular what formula. But so what is the name of this compound here? So that is the reason why you must know and master how to what name organic compound. The name of this guy here is called 2-methyl butane. 2 what methyl what butane. Do we have 2-methyl butane in the option? Now 2-methyl butane, 2-methyl butane. Oh, it's like you cannot have two the same option. You cannot have two the same option. Yes, but yes, pentane. Pentane, yes, that is a mistake. So that one is what pentane. So you have 2-methyl pentane, which is wrong. It's not 2-methyl pentane. It's not butane, wrong. It's not 2-methyl propane, wrong. The answer is what 2-methyl butane. This is what is the answer. Just done. So now, like what I say, this is what is a revision class on isomerism. You get, and these are what commonly asked JAMB questions when it comes to what isomerism. So you really want to what take this video serious. Now, but what will help you, like what I said, I will repeat this thing till I end this class. Please go and check my complete video on what? Go and check my complete video on isomerism. The structural isomerism, we are talking about chain, positional, and functional. So I can understand it very well. Then go and check out my stereo isomerism, which I talk about geometrical isomerism. Geometrical isomerism, we are talking about the cis and trans isomerism. I'm going to check out what my optical isomerism. You get. So now let's look at what number 6. We are following structural isomerism. So which of these are what structural what isomerism? So let me write this place here so I answer that question. So you have which of these was structural what isomerism? So now remember structural isomerism, they have the same molecular formula but different structure. So it can be chain, positional, or functional, right? So here we have propanoic acid and what pentane 1,2-diol. So now, like what I told you, the easiest way you can know if compounds are isomers is when they have the same molecular formula. You get that? So how do you know if they have the same molecular formula? Therefore, draw out their structure. So here we have propanoic acid. Propanoic acid is what? Is a carboxylic acid functional group. So group means what? 3 carbon. 3 what? Carbon. 1, 2, 3. Is okay. 1, 2, 3. With what? Carboxylic acid functional group. Now we're talking about oic. It's like this. It's called arachidonic acid. Arachidonic what? Acid. It's okay. So this is what functional group here. So you have one of the carbon is going to be this one here because 1, 2, 3. Just on 1, 2, 3. So it's going to be CH3, CH2, C. It's just called propanoic acid. Propanoic what? Acid. Just on. Now the next thing you want to do here is what? Propane 1,2-diol. Now is the propane is what? 6 carbon 1, 2, 3. But here we have 2 OH group, OH and what? OH. That's why it's called. That's why you must know how to draw organic structure. Propane 1,2-diol. That is diol means 2 OH group. Alcohol OH with what? That is 2 of them. So that's why it's called diol. So it's a carbon number 1 and carbon number 2. It's okay. So you can see it like this. OH and what? OH. Can you see that? So hydrogen, 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 hydrogen. But first, let's see if they are going to have the same molecular formula. So how many carbon do you have here? 1, 2, 3. 3 carbon, right? How many hydrogen do you have here? How many hydrogen do we have here? 3, 6. So here we have 3 hydrogen, 3 carbon, 1, 2, 3, 3 carbon. How many hydrogen? Here we have 3, 5, 6, 6. How many oxygen? Here we have 2 oxygen. Let's check so here 1, 2, 3. C3. Let's look at what numbers of hydrogen, right? 1, 2, 3, 4, 5, 6, 7, 8. 8 O2. Now, 2 of them are not isomers of each other. Do you understand? You know the reason why? This guy here is having what? C3H6O2, right? This guy is having what? C3H8O2. You can see that these and these are the same. These and these are the same, but the hydrogen are not the same. So they are not isomers of each other. So this guy is what is wrong. That is why as a chemistry student or organic chemistry student, you must know how to what interpret structure. You must know how to draw structure when you see them. Do you understand? Now, this guy and this guy are going to be the same thing. They are not isomers of each other. No, here we call ethanoic acid. Here we have propanoic acid. They cannot be the same. They cannot be the same molecular formula. Do you understand? Because this one is going to be 2 carbon atoms. They're going to be what? 3 carbon atoms. Do you understand? So they're not the same. Now, this one just like what I've just done here. Here we have ethane 1,2-diol, ethanoic acid. You understand? So they are not, because if you check it very well, this one is called ethane 1,2-diol, which is also similar to this one here, propane 1,2-diol. And it's called ethanoic acid, propanoic acid. So they are not the same. They are not isomers of each other. Do you understand? Now the next thing you want to look at is what? Propanol and what? Propanol. So how do you draw them? So let me wipe this place out. Let me wipe this place out. So here we have propanol. Now, whenever I see propanol, is what is a alkanal functional group. So it's all aldehyde functional group. So here we have alkanal, and what? Alkanol. It's okay. So you must know how to draw that structure. Just I must know how to draw structure of what? Propanol and what? Propanol. I've done a complete video on that. I've done a complete video on what idea that what ketones and the nomenclature. So you should try as much as possible to go watch that video, right? So 3 carbon atom. So alkanol is like this. R here, C. It's okay. This is the structure of what? Alkanol. Structure of alkanol is just like RCOH. It's okay. So this is it here. So in the sense that alkanol is like this. Because that 2 of them have the same functional group. 2 of them have what the same functional group here. But here we have RCOH. Here it's going to be RCORO. Do you understand? So 2 of them have the same functional group. So if I talk about propanol, what do you mean? It means that here we have 1, 2, 3, right? Now this functional group is going to be this guy here. Can you see that? You're going to be this one here. Then here we have hydrogen, and what? Hydrogen. Do you see that? The same thing with this guy. Going to be 1, 2, 3. Now, the functional group is going to be at the middle. So you have CH3. Here we have what? CH3. So this is called. So if I should write it in what in a condensed formula, so you understand better. So it's going to be CH3, CH2, C. You see that? So now let's see if they have the same molecular formula, because after drawing their structure, the pair of the structure, now the next thing you want to do is to check if they have the same molecular formula. So if they have the same molecular formula, then they are what? They are what? Isomers of what? Each other. So how many carbon atoms do we have here? 1, 2, 3. C3H. How many hydrogen? 3 hydrogen, 2 hydrogen, 1 hydrogen, which was 6. Because 3 plus 2, 5 plus 1, 6. Oh, how many oxygen? 1 oxygen, right? So now the molecular formula of this compound we call propanol is what? C3H6O. What about this one here? C3H6O. Correct. 3 hydrogen, 1, 2, 3. 6 hydrogen, 1, 3 plus 3, 6, 1 oxygen. So do they have the same molecular formula? Yes. Are they the same structure? No. They have the same molecular formula. They are not the same structure. So the answer is what? Is D. Do you understand? The answer is what? Is D. Hope you understand. Now, the next one to do, let's want to look at what is question 7. The type of isomerism shown by cis and trans isomers is what? So the answer is what? Geometrical isomerism. Is geometrical isomerism that have what? Cis and trans and E and what? And Z. The answer is what? Geometrical what? Isomerism. So we are going to end our video here. More of this video like this will be coming up, like past questions, how to answer past questions coming up, both in math, English, and what and physics. So if you're not subscribed to this channel, please never you subscribe. I will leave the link at what? I will leave the link for what isomerism at the description below. I also see some at the what end screen. So you can check out other videos on my. I've done the calculation aspect of chemistry, majority of the calculation aspect of chemistry, oxidation, reduction, oxidization, reducing agents, class principle, and the rest. I've done a lot of video on that, on those topics. So you can check out those videos. More of this video will be coming up here. Please kindly share this video to your friends who are likely JAMB so that they too can enjoy this video. Thanks for watching. See you in next video.